So the first one we're going to learn is polygon. If you were describing the word polygon to a second grader, what would you say? A shape with multiple sides. Good. So what you're going to do is a circle a polygon? No. So you already have the idea of what a polygon is. Here is the way that we're going to word it in class. It is a closed figure formed by line segments, and each side intersects exactly two other sides. It is a closed figure formed by line segments, and each side intersects exactly two other sides. So closed figure formed by line segments, and each side intersects exactly two other sides. So here's what it means by closed. What kind of pet do we want? A pet. A what? A turtle. I don't know how my turtle drawing skills are. Oh, that's a turtle. That's a turtle. It's solid. It's got a little tail. Make sure you pick up notes. So if a turtle were in like a gated area, would the turtle be able to escape in the way that it is drawn? Yes. Okay, it has an open side, right? So this is not closed. Closed means no animal would be able to get out, that kind of thing. It's formed by line segments. So line segments and no curved arches. So like this would not be a polygon because it is a semicircle. And then the last part, it says, and each side intersects exactly two other sides. It means every corner, so like this corner we're looking at, every corner only intersects two sides. So this one would intersect three. So this would not be a polygon, okay? Not as a whole picture. So it's a polygon. What I want you to write about the sides are line segments. The sides are line segments. You can just write that. The sides are line segments. You're a Dallas fan? That's rough. Sides are line segments, and a vertex, which is said vertices when it's plural. The vertices are the corners. So that's all I want you to write. The vertices are the corners. Okay. So of your shape, the corners, those are your vertices. Vertices is plural for vertex. Okay. So a vertex of a polygon is an endpoint of a side of the polygon. All right, so last one is convex. All line segments point outward. All line segments point outward. And I'll show you what it means by point outward. All right, so let's do a pentagon and a star. You're just going to see my amazing artistic skills all in this class, so just be ready to be amazed. So here's what it means. Convex, all line segments point outward. So here's like the generic, pretty much the center of the polygon right there. None of the segments go towards the center. So that makes this convex because none of the segments dip inward. Does anybody know the opposite of convex? Concave is going to be the opposite. So concave, like in our star, here's the center of the star. Some of the segments go towards the center and then away, and then back towards the center and then away. The going towards the center, so all of these going inward, is what makes it concave. Apparently I can't spell over here. I should have said convex. Okay, so concave goes towards the center. Convex, they point outward. None of them go towards the center. So you'll see that. We'll move on to the There's like a chart. Polygons are named by the number of sides they have. What you learn in this chart will be on your midterm. That's how important these things are. You actually know a lot of them. A three-sided figure is called a triangle. So yes, that is on the midterm. You already know one. A four-sided figure. Those are all types of quadrilaterals. So square, rectangle, rhombus, parallelogram, those all have four sides. We actually have an entire chapter on quadrilaterals. We do it in chapter 7. So you'll see that there. Quadrilateral, 5 sides. We have a government building named after this. Pentagon. 6 sides. Hexagon. Yeah. 7. Close. Close. It's with an H. It's heptagon. Heptagon. Eight sides. Octagon. 9 sides. Sounds like 9, but it's not. It's nonagon. Nonagon, ninagon. It's non. 10. Think of how long, what do we call 10 years? It's decagon, because deca means 10. So decagon, we will do 11, and we will do 12. And then that's as far as we go. Okay. On this, the book puts it out of order, so don't ask me why. 12 comes next, and 11's at the bottom. This is literally what's in your book. 12, so what I want you to think of, any of the teens, so 11, 12, 13, 14, 15, they all end in decagon, because what does decagon mean? 10. So it's going to have a prefix, and then decagon. So what you want to think of, 12, what is the Spanish word for 2? So it's dodecagon. It's close. It's dodecagon. You're not required to know beyond that, but they're pretty obvious. And at one point, if you list it as its proper name, I would give you bonus points. I can't remember if that's this chapter or in chapter 7 that we do that. But like 13, what is a normal prefix for 3? Tri, and then decagon. That's 13-sided polygon. There are names all the way up until 96-sided polygon, which is whenever you have so many sides, they end up looking like a circle. But they do have an official name, and it's a hot mess. So, but we only are required up until 12. After that, you can put the number and then gone. So 96, gone. 84, gone. 27, gone. So, and the number and then gone. Number 11, you do need to know this one. There are 2 names, but we use hendecagon in this class. Hendecagon. Hendecagon. But anything after that, you're not required to know. You would just write number gone. Yes, ma'am. We use hendecagon. I've heard someone else say septagon earlier for 7. I don't know if at some point in a book it said that somewhere. There are synonyms, but this is what we use in this class. So, all right. So that being said, you'll have a question like this on your test. Fun fact: these are actually one of the most commonly missed questions. So, it's because when I say classify, you need to know what I'm asking for. The classifications are all on this page. So a 4-sided polygon, you would write quadrilateral. A 10-sided polygon, you'd write decagon. So you count the sides. So what I recommend is you can count the sides or you can count the corners, which is what I prefer. So you can count the corners 1, 2, 3, 4. Because the amount of corners there are, that's how many sides there are. So then what would the classification of this polygon be? It's a quadrilateral. And then, I'm just going to put a dot in kind of the center. We need to decide if it's convex or concave. Do any of the sides come in towards the center? Yes, these two come in towards, so it is concave. So the sides cave in. That's a way to remember it. Letter B. Count the sides. You got 1, 2, 3, 4, 5, 6, which is hexagon. Do any of the sides come inward? No. None of them go towards the center, so this would be convex. All right, this is the next one. We're going to count how many sides it has. It does have 5. 1, 2, 3, 4, 5, which makes it pentagon. And then do any of the sides come in towards the center? They do, these two. So this would be concave. And then last, got 1, 2, 3, 4, 5, 6, 7, which makes it heptagon. Ooh. Heptagon, and then convex or concave? Convex. Boom. Good. So now we get to kind of the meat of everything, the perimeter. Can you describe what a perimeter is? The border. Okay, good. It's going to be the length around the geometric figure. So we're going to find the length around a geometric figure. So what is the physical perimeter? I'm not asking the number. The physical perimeter of your backyard. What does it look like? A fence. What's the perimeter of this room? The walls. Okay. So we're going to find the perimeter. In order to do that, you're just going to add all the sides. Okay. So this first picture, do we have all of the side lengths? No. What it looks like is we've got a rectangle with a piece of it caved in, right? It's concave. So here is what you're going to do with your highlighter. I'll show you why first. If this were a regular rectangle, right, this side and this side would be the same length. Do we agree? We do. The only thing is this dotted portion was pushed in, correct? So what you're going to do with your highlighter, highlight all these vertical lines together. Highlight them. I didn't mean together. Just highlight them. So, if from here to here is 6 and here to here is 7, what is the full length of the line? 13 meters. This is where you would take your second color. The same thing with the horizontal lines. The opposites would be the same length. However, this dotted portion was pushed in. So, the full length should be 13 meters. We know this portion is 8. So what is the missing portion of my perimeter? 5 meters. Good. So from here, how do we find the perimeter? Add all the sides. So here's what I ask of you. When it comes to showing your work, just show me what all you added. You can plug the rest in your calculator. I do recommend having out your calculator for the remainder of this lesson. We're going to take 13, add it to 6, add it to 8, add it to 7, add it to 5, add it to 13. So this is you showing the work, that's all. Then you can plug the rest into your calculator. what is it? 52, and then we'd say meters. Meters. Please keep in mind that these are not always drawn to scale. So you can't ever say, well, it's a little bit smaller, so that means it's got to be, you can't just guess, because these are not drawn to scale at all. I would find them on things, on different people's notes, or like different worksheets that we could work together, and then I made them larger, I made them smaller, so it is not to scale at all. Okay. The last one we'll do like this. These didn't print. You want to put dashes here? What do those dashes mean? Yeah, they're congruent. So we're going to do something similar here. Depends on what you want to do. We know the vertical line is 15 millimeters, and this one is also going to be 15 millimeters. But I probably wouldn't highlight this inside portion because it's not super helpful. It's pretty obvious. What will the length of this missing piece be? Yeah, it's going to be 10. Because the other portion is 10. So what I would do with my highlighter is highlight the 30 millimeters. And then I would highlight all of the horizontal lengths. Because again, this 8 millimeters, if it is 8 millimeters length down here, it's 8 millimeters length up here. So, of the 30 millimeters, how much is spoken for? 8 of it. So subtract, what's 30 minus 8? 22. So we have 22 millimeters left to split evenly, correct? So how do I split 22 into 2 congruent sections? Divide by 2, and that makes 11. Alright, so from here we're going to just add the sides. So I'm going to start with 11 plus 10 I know it's a lot of numbers, but what does it come out to? 110 millimeters. Good. We'll come to the last problem we do together. This is the main portion. We're going to take what we were doing and put it on a coordinate plane. The only difference is these are not going to be composite shapes. Composite means a shape was cut out or a shape was added on. So like these are 2 rectangles, right? In this portion on the coordinate plane, it's just going to be 1 rectangle or 1 square or 1 triangle. Okay, so it's less complex. We're going to find the perimeter of triangle ABC. So you see this little triangle, it means we have triangle. The other thing that told me is I only have 3 coordinate points, which means triangle. What I want you to write down is we're going to have to find lengths here. So to find the lengths, if it is a horizontal or a vertical line, you're going to count. If it is a diagonal line, you use the distance formula. So I do want you to write that down. If you're given a horizontal or a vertical line, you can just count. If it's a diagonal line, you have to use the distance formula. Or you could use the distance formula on all of it, but I don't think that you want to. So if it's a horizontal or vertical line, you can count. If it is a diagonal line, you must use the distance formula. Whoop, sorry. All right, so you're going to draw the x and y axis. And then we're going to plot each point. We've got point A, which is -2, 3. So from the origin, -2, this to the left 2, and then up 1, 2, 3. Point B is 3, -3. So from the origin, I'm going to go to the right 1, 2, 3, and then down 1, 2, 3. And then C, -2, 1, 2, and then down 1, 2, 3. So I know this is a triangle. What can I do to signify that this is a triangle? It doesn't look like a triangle yet. I can connect the dots. So from here, we're going to find the perimeter. So we're going to add all of these side lengths. So we could do the easier ones first. We've got a vertical line, right? From here to here. So you can count 1, 2, 3, 4, 5, 6. Did I count that right? 1, 2, 3. Oh, yeah. Sorry, I didn't zoom in for that. And then we can do the horizontal line from C to B. 1, 2, 3, 4, 5. The only one that we cannot do that to is AB. So we're going to have to find the length of AB. So we're going to use the distance formula because it is a diagonal line. So distance formula is the square root of x1 minus x2 squared plus y1 minus y2 squared. And then I always write the formula with blanks so I can just plug in. What are the only 2 points I'm using? A and B. Why am I using those 2 points? Yeah, that's where my diagonal line is. Okay? If I used another one, if I used A and C, guess what my answer is going to be? It's going to be 6. You don't need to find the distance of AC. We need AB. So we're going to ignore point C for a minute. You can label your points x1, y1, x2, y2. So what is the first x I'm going to plug in? -2. And the second x, 3. The first y is 3, and the second y, -3. So I plug in -3. There's already a negative in the formula. So what happens here? Positive, yeah, plus. We'll try to speed up a little bit. What's -2 minus 3? -5 squared is 25. 3 plus 3 is 6. Squared is square root. So 25 plus 36 is 61. And then the square root of 61 right into the 10th. 7.8. So this is not the final answer. What did we just find? Yeah, the length of AB, that diagonal line. So we know this one is 7.8 in length. So what do we do to find the full perimeter? Add them all together. Good. So perimeter will equal 6 plus 5 is 11. 11 plus 7.8 is 18.8, and then units. Good. So that is the last example. I will say that on your classwork, you will have a rectangle to do. The reason we didn't go over that is once you've plot the points, they're all horizontal and vertical lines. So to find the perimeter, what would you do on all of these sides? You would add. You would count the boxes and then add them together. Okay, so that's why. We're going to do one like that tomorrow, but I felt like we were ready for our work today. You're going to do a classwork assignment. The graph is just for visual understanding. It's not actually part of the answer on this homework. You do need a graph just so you can count when you need to count. Any diagonals you use, you have to use the distance formula. And then we're finding the perimeter on all of these. So find the lengths of all the sides and add them together.